Okay, so now we're going to use SOHCAHTOA. So I'm going to write this up here, SOHCAHTOA. These are our trig ratios to help us solve for different parts of a triangle, either the sides or the angles. And we're going to do that. I think the easiest way to do this, and the first thing I like to do, is look at the angle that I'm working with. So this is the angle that's marked, the angle that I'm working with, and I want to label the sides of the triangle in relation to that angle. So the side 6 is opposite that angle. X is adjacent or next to the 20-degree angle. And so now I want to look at the things that I have labeled, and I want to say which of the trig ratios uses adjacent and opposite. So that would be tangent. So I can write out an equation here. Tan of 20 degrees is equal to 6 over x. So I've set up an equation. Let's think back. Let me do this first. We can say tangent of an angle is equal to the opposite over the adjacent. So now we fill in what we know. Tangent of 20 degrees is equal to 6 over x. I'm going to put this over 1. So in order to solve this, I'm going to use the idea that these are two ratios that equal to each other, so they're a proportion. And how do we solve proportions? We cross multiply. So I'm going to get x tan of 20 is equal to 6. Divide both sides of tan of 20. I'm trying to get x by itself, so my goal is to get x by itself. These cancel out, and I get x is equal to 6 tangent of 20 degrees. So I'm going to plug this into my calculator. This goes into my calculator. So let me pull up the calculator here. And so when I pull this up, what I'm going to put in my calculator, I'm going to type in 6 divided by tangent of 20 degrees. Hit equal, and I get x is equal to 16.48, which gives me the side I was looking for. So that side x is equal to 16.48. Let's try another one. This one's a little bit different, so it's important to listen to this one. So I'm going to do the same thing. I'm going to start with marking the angle that I'm working with and labeling the sides in relationship to that angle. This would be my adjacent. This is my hypotenuse opposite my right angle. And so when I look at my trig functions, which one uses the hypotenuse and adjacent? That would be cosine. So I know cosine of theta is equal to adjacent over hypotenuse. So I can write this as cosine of 48 degrees is equal to adjacent, which is x, over hypotenuse, which is 10. I'll write this as two ratios equal to each other or proportion, and I'm going to cross multiply. That's going to give me 10 cosine 48 degrees is equal to x. So I'll plug this into my calculator, and I'm going to end up with, let's do that. So when I pull up my calculator, I'm going to clear this out. I'm going to put 10 times the cosine of 48 degrees. And I end up with 6.69. So my x is equal to 6.69. And that's the side that I was looking for. So not bad. There's one more example, example 3, and this one's a little bit different, and so it's important for you to listen to this one. This one is now looking for an angle. So if you notice, the unknown piece here is the angle. So when we're trying to find an angle, this is when we use the inverse. We did this before break. So let's mark the angle that we're working with and label the sides in relationship to that. This side is opposite. This side is opposite the right angle, so it's my hypotenuse. So I look at SOHCAHTOA, and I want to decide which of the trig ratios am I using. Sine of an angle is equal to opposite over hypotenuse. So sine of x is equal to 5 over 12. So we're looking for an angle here. So let's think about this. We need to find the angle. So we need to use sine inverse. So I'm going to write this as the sine inverse of 5 over 12 is equal to x. So let's see how we'll do that on our calculator. So I can clear this out. Sine inverse, I'm going to use the sine inverse of 5 divided by 12. Hit equals. And so x is equal to 24.62 degrees. So the angle we were looking for is 24.62. So always remember, when you're trying to find the angle, you want to use the inverse on your calculator. The next video will be the last example, and that's how to solve a full triangle.